So the next thing will be what is a constructor? That we have to see. So why we use a constructor? First thing, to initialize the variables we can use constructor. See, we have seen one thing, like for the variables, if I don't give the value, it gives error. So to give the values, initially, we can use a constructor and chain. So how to define a constructor? It's a predefined structure. We define the constructor using similar to like df function, but we have a predefined thing underscore underscore init underscore underscore cell. So this is the constructor in Python, and this constructor is used to initialize the values. So at what time this constructor gets executed? If you see, for a method, we need to call it either using by the object or by the class name. So what about this constructor then? So constructor gets executed when object is created. Means if I create one object, one time it will execute the constructor. So if I create 10 objects, it will execute 10 times, right? So what you can say, that is for n objects,
n
times gets executed, right? So that's the first point. And types of constructor. For a function or a method, we had these two properties, right? What are those two properties?
Yeah, it will initialize the parameter and have the
the
return.
returns.
Right. Return will be there and parameter will be there, right?
Yes.
Constructor, you can say has only one property,
No return type.
is parameter. So we cannot have return. So what's the last point you can say? Constructor cannot return any value, right? So that's the first thing you can say. Constructor cannot return any value. And now what we have is types of constructor. Based on the property only you can define it. So first thing will be without parameter. So what is it without parameter means? Directly you can specify it as here zero argument constructor also you can say. What is it?
Zero.
And the next thing is with parameter, right? Parameterized constructor means without any parameters with some parameters. These two things are the types of constructors, right? So how to give a particular without parameters? Let's write a program. I'm taking an example of a student, and this student consists of a like space I have given a constructor. So what is a constructor? Underscored init and self. This is without any parameters, right? So how to use it? Why to use it? The first thing, we use it to give the values for a variables, instance variables. So instance depends on the self also, right? If I say self.id 1023, the value is assigned as 1023, and self.percentage, what I'm trying to give, some 78.3. So there's a percentage, right? So this is a constructor. Now let's write a particular method. So give some space, define details, self. So we have to print those details, right? id equals to, what is that id? You can say self.id. What does self represent?
So instance.
Self represents the
Reference.
class, right?
Yeah.
So this is the way we can initialize them and we can access them, right?
So without constructor, we can initialize like class variable, and we can do the desired output, or we can use constructor. What is the use of constructor here?
The thing is, without the particular object creation, like if I give the variables here, id equals to, we need to give some value, right?
Yeah, we need to initialize. Okay.
So the same values will be there for all the objects.
No.
We'll show you the difference once we complete this example. You'll understand. Like here, we are able to give the values, right?
Yes.
And I'm trying to execute them. Like say Rahul is a student, so I'll directly say Rahul is a student, and I'll just have to say Rahul.show. So what I can say?
Show is not right, or is we don't have any show function.
Come again?
Show is a function or a keyword.
No. Actually, I wrote it wrong. Just give me a second. Python program version. What I've written?
It's a print. Okay.
Yeah, details actually.
Yeah. Okay.
What function? What we are writing here? We have to call it, right?
Yes.
So what about this constructor? We are not calling it because once this step executes, it gets executed automatically, right?
Yes. Okay.
Right. So save this thing and run this part. Cd space Python program, cd space batch 1, py space. So what is that constructor.py means? We got 1023 and 78.3, right? But the thing is, if I create one more object, what will happen if I call the details method?
It will be the same.
It will be executed.
It will be the same values, right?
Same.
If you write it without the constructor also, the same thing is happening. But what is the advantage of constructor? We have a concept known as parameterized constructor. So if you want different values for different objects, what I can do, I can directly write id comma percentage here and fill these values with id and
percentage.
percentage, right?
Yes.
So what I have to pass here? 1023 and 76 point
Whatever, yeah.
and 1024 87.3. Say this thing. If I run the same program, I got different values, right?
Mm-hmm.
So how I got the different values? Because of the parameterized constructor, right? So what is the advantage of parameterized constructor? If you want to give different values to the variables for different objects, then we can use this parameterized constructor. And zero argument constructor, if the values are same. Like for example, if I go with the pi value, what is pi value? 3.1414, right?
Yes.
These values which are common to all the objects, we write it inside a zero argument constructor. So what will happen when the object gets created? Directly the values are assigned, right?
Mm-hmm.
So constructor is required so that once we create an object, few functionalities should be done directly. So this will be done directly, right? That's the reason constructor is important. Like the programmer doesn't have to call it. Once the object is created, it gets executed automatically, right?
Here the self is a must keyword here. Without self, we cannot create the constructor.
The same thing, like inside a class, if you want to access something, let's say, takes zero positional arguments, but one was given. So what you understand, you need to have that self. Without that, you will get the same error every time.
Okay.
So it's mandatory to have a self. Okay. So you can just call it using that self dot id and self. Then only we can say it as a variables, instance variables, right? And static variables depends on the class name, right?
Yes.
So that is zero argument constructor and a parameterized constructor, right? Is that point clear? Any doubts?
Yeah. Yeah.
Yeah, clear.
Right. So constructors are important because programmer is not executing them, like not calling them. Those will get executed automatically when you're creating an object. So few things will be there which must be done once the object is created. So those things we write it inside a constructor. That's the reason constructor is very important. Okay. And we have seen the difference between the zero argument and the parameterized constructor, right? What is the difference you can say?
Parameterized can have a multiple values for multiple objects.
Different values for different objects.
Yeah.
Zero argument means if we want to have same value
Different
for all the objects, then we use a zero argument constructor. If we want to have different values, then we use
Parameterized.
different values for all the objects. Then we use a constructor thing, right? Parameterized constructor, you can say. Okay. So these are the different scenarios where we use a particular constructor, you can say. Next, after this, so after the constructor, we have in OOPS the inheritance concept. So what is inheritance? Why we need a particular inheritance concept? Consider I have a particular class. One class is there. What is it class? Square. And there is one more class that you can call it as sum. So now, if I want to find the square, like a is there, some pi value. If I just say a into a, it's sufficient, right?
Mm-hmm.
That whatever the value is there, for that it will execute this logic. Now, to find the sum, we need again a b value and a c value, right? So b plus c is required because two variables are required to perform the addition. So what I want to do is, instead of using c, I don't want to use the c. Already a is there inside the square, right? That variable I want to reuse inside that sum. Reuse means the a must be used inside the sum. For that reusability, if you want to reuse the variables, that sum should have square inside it. So if you write this step, it indicates what square variables and methods are accessed inside the sum. There's a single thing why we use inheritance is reusability. I want to reuse the variables or the methods. Then we can use this particular thing. So it will be saving the memory, right? Because if I declare another variable c here, memory is getting wasted. So instead of that, we can have that same particular variable of square class being used inside the sum class. So we have different terminologies for the particular square and sum. You can say super, you can say base, you can say parent class. So these are the terms used for it. And we have a terms for the sum like subclass, derived class, or child class. Superclass or subclass, base class or derived class, parent class or child class. That's a terminology. Like for the parent properties are being accessed inside the child only, right? So whenever I say sum of square, only square properties and methods are being reused inside the sum, not the sum inside the square, right? So one class properties and actions are being accessed inside the another class. That's the main reason why we need to use a constructor. Is this point clear? Any doubts?
That is okay.
Now, one thing is there. For the square, is there any memory? Inside this class object, which has memory, object, right?
Object.
So class doesn't have memory. Like if I want to access that A inside the sum, means that A is nothing but the square object. The square memory should be there inside the sum. Then only I can access that A, or else I cannot. Because for any property, the memory is required, right? And A is a property of square. So when I have the object of square, then only that A will have some memory. Then when in the inheritance, what happens when I create an object for sum only at the time of inheritance? This is the advantage we have. So when I create the object for sum, automatically it allocates a memory for the square. So what I can use here directly square. So at the time of inheritance, if two classes are there, superclass and subclass, we create object only for the subclass, not for the superclass. Because already when I create object for the subclass, it contains the memory of the superclass inside it, right? So 1 plus 1 offer. If you create one object, you will get automatically another object. And we don't have to create the square object separately, right? No need to waste the memory. Just create for sum. Internally it has square. And whatever the actions or the methods are there, we can execute them. Okay? So is this point clear? Any doubts?
Clear.
No.
Yeah. So Vision, is it clear? Like what is inheritance? How we accessing it? We need a memory and create object of surplus. It automatically creates for the superclass. So now next thing. So if I want to write this program, can you tell me what is method definition? Method or function definition, why we need to write that?
Method is
Method are used to like give a set of instruction.
Set of instruction. Yeah.
What we do in
the
the set of
particular
instruction.
task we had.
Yes, to perform a task.
To perform it.
So it's a simple thing like print, it's printing the output. Our input, it's taking the input. Why we use these things? To do some work, do some task, right? So here also squares, one thing I need to take a particular input, or you can say accept, right? And here accept means it will accept the values of A. After that, I have to write one more particular method for the logic. That is a SQR, right? So two particular blocks are there. One is for the input, one is for the logic. So that I can reuse them separately if I required. Input and the logic, right? Next. After this, here also like define, we need to take the value, right? So I'll just say give. Don't take the same name again because we have a concept known as polymorphism. Once the polymorphism completes, you will understand why I said that. So here accept is given. Don't use the same names again inside the inheritance. Don't use the method names sames. Okay. So here the next thing will be give. It will give the value for B, and then we need to find the addition of two variables. What are those? A plus B. Okay. And everything contains a self, right? These methods every time the instance variables must and should have self because it represents the class object. Now, so the requirement is clear, right? A square class which contains two methods. One is acceptance SQR and a sum class which contains the two methods give and add. And we have an inheritance concept where this A is being reused and we create object only for the sum and call the methods accept, square, give and add, right? So let's write a program for that. I have a class square. I can say accept of self. So self dot a equals to int of input. We need to convert this, right? So I'm just taking that value dynamically. Enter a value. Next, after that, we need to write one more thing known as SQR. So what is SQR? Have that output square equals to self dot a into self dot a. So a into a is the logic, right? Next, we have a class sum, and square must be written inside the parentheses. Then only we can say that square properties are being accessed inside the sum. After this, define that value. So what is that value? Give. For b, I need to write this thing, right? Self dot b equals to int of input enter b value, and we have a particular addition of the values. So what I can do directly, print sum equals to self dot a plus self dot b, right? Now, for which class we have to create object, square or sum?
Sum.
Where?
Square? No, sum.
If I create for the subclass sum, then it allocates the memory for the square, right?
Okay.
So we need to create object for the
Sum.
not for the square.
Oh, yes.
We are not creating. Clear?
Mm-hmm.
We are not wasting that again memory because already sum has a square, right? So what I'll do, I'll directly write s equals to sum and s dot accept is the first thing, then s dot sqr and s dot give and s dot add. That's it, right? So save it as inheritance dot py. This is inheritance dot py. Save this thing, and after that I need to run it. So what is it? Value 5, square is 25. If I give 10, 15, we got the output, right? Any doubts in this thing? So if you understand this single inheritance, there are different types of inheritance. All those things will be similar. Just we need to understand whenever we create object for the subclass. it will be sufficient to call the superclass methods. Okay. So shall I continue? No doubts, right?
Yeah, Ravi.
Yeah, not.
Let's do one thing. You can see that 5 values there, and for the square is completed, and then b value if I'm giving. So the same 5 values taking to add, but I want different value now. I don't want the same 5 to be reused. I want different value. So what I have to do? I have to call accept again. Let's see what happens. If I call accept again, I'm giving 5, and again it's asking for that value 10 and 20, 30. So for the square, separate value, and for the multiplication, separate value, right?
Some separate way.
Yeah.
Some separate value you have given. So how it is possible? Because of reusability. We can reuse the accept twice, right? So I've written once, I've called multiple times. That's a reusable thing. Now suppose if I create square objects separately and some objects separately, what happens? Like consider I'm creating some x equals to square. I just want to check what happens if I call this square and sum separately. And this is sum, right? So what I have to do now, execute the same program. I've called accept and square using the square object and sum using the s dot give and s dot add. 5. What is it? 5 value? 25. 10. The sum object has no attribute a. Why? Because here I'm trying to access this square separately, right? And the sum separately. So that's the reason I got the error that some attribute has no value like a. Here you cannot access this thing until unless you are using the same object. That's the reason when we have superclass and subclass, we create object only for the subclass. Now understood? And the next thing, what are the types of inheritance? So whenever inheritance we use this classes, we create object only for the subclass, not for the superclass. Right. So after this, how many types of inheritance are there? What are the different types? What is inheritance? Right, you can say acquiring the properties of superclass to subclass, or I can say reusability. In a single word, we can say that inheritance, reusability. And what are the types of inheritance? Types of inheritance. So what are the types you can say? Single level inheritance. So just now you have seen single level inheritance, right? One class trying to access the other class properties. So this is single level. And next thing, we have multi-level inheritance. We have hierarchical inheritance. and we have multiple inheritance and hybrid inheritance is also there. Okay, so these are the types of inheritance, and just we have completed the single level inheritance, right? So what is multi-level? How we have to access that? How we have to write these things? Multi-level inheritance. So multi-level is nothing but there is one
Formatting.
class and there is another class, right? After that we'll be having one more class. Like that, one after the other, if you write that multiple classes, we can say multi-level,
So
right?
that is a square under some, and under the square maybe one more class.
Like cube, sum, multiplication also we can say, right? But let's take a real-time example. Like we have electronics, and electronics nothing but mobile is an electronics, right?
Device.
Mobile is an electronics, and we have one more thing known as like OnePlus. So OnePlus is a mobile, right? So this is multi-level, you can say, where electronics is a class, super class, and mobile is a electronic, and OnePlus is a mobile, right? So consider for all electronics, what's the common thing for all electronics? We have a circuit in all the electronics, right?
Yes.
Yeah.
And for all the mobiles, charger is required. Without the charger, we cannot do that thing, right? And OnePlus mobiles, for all the mobiles, we need a RAM, right?
Mm-hmm.
RAM or memory card, you can say. So a phone without RAM doesn't exist. We have RAM for that phone, right?
Yeah.
Understood the example?
Mm-hmm.
Yes.
So it's multi-level because from electronics, all the features are available inside the mobile. And electronics and mobile features are available inside the RAM. So if we create object for OnePlus and call the charger and circuit, it will get executed, right?
Yes.
Yes or no?
Yes.
So
Yes,
that is
yes.
what advantage of inheritance. So once we create object for OnePlus, that is sufficient because OnePlus has a circuit, OnePlus is an electronics, and OnePlus is a mobile, right? We can say this thing, electronics and a mobile. So can I write Dell is a mobile? Is it possible? Can I have a mobile and Dell as a subclass?
Yes, maybe Dell is manufacturing mobile.
In the real time, I'm asking. Presently, there is no Dell mobile, right?
Yeah, correct. Yeah.
So the concept should be in a such a way that it should match that real time scenario. The examples also should match the real time scenario. Then it will be easy, right?
Yeah.
Dell is an electronics, you can say.
Yes. Dell is an electronic in the sense, laptop if you have, it's possible. If you have
Correct.
another example scenario, in the electronics,
can have laptop.
Apple, take the Apple. Yeah.
Then we have a laptop, right?
Yeah, laptop is electronics and Dell Apple can be.
So, and Dell is a laptop, right?
Yes.
So if I say Apple means it has both laptop and mobile. So
There is another type of inheritance then that we'll see at the time of multiple. Okay, so laptop. We can give one more example like sports. Sports can be of like say indoor sports will be there, right?
Mm-hmm.
And indoor sport consists of chess, caroms,
Cheating.
But
different
yeah.
things. Or you can also say sports outdoor also.
Yeah.
And football is an outdoor game, we can say, right?
Yeah.
Mm-hmm.
Cricket is an outdoor game, we can say. Correct?
Yeah.
So these are real time scenarios. So write programs on this. Like just a particular circuit and which will be called using the 1 plus. Okay. So what I have to do? I need to write a program on this thing, right?
Mm-hmm.
Let's write for sports also. Like in the sports, what things are there? What are the methods you can write? Referee,
Referee score.
referee will be there, or you can say umpire. Without umpire, isn't any sports played in the international level? No, right?
No. Fair and
And what I can say, indoor,
participant.
yeah, participants or players. Players can be multiple or depends on the game, right?
yeah.
And what is for the chess?
Chess.
More coins.
Correct. Coins.
Mm-hmm.
So we require coins for the particular chess, right?
Mm-hmm.
And this is the way we can write the program, like the functions. Anything you can write, electronics, mobile, one plus. So let's see for the electronics if we are able to write. So what we have is we need to write a particular class, electronics, and that is nothing but the class, right? Start the block. After that, I have to define a particular
Mobile.
circuit, you can say.
So,
Self is mandatory. So what I have to print circuit used is some circuit name EFXC. Next, after that we have a class known as mobile, which is a subclass of electronics, and we need to have a particular charger. So what I can say, 5 volt charger is required, right?
Mm-hmm.
And another class is there, OnePlus, which is a mobile. We can define what is that, RAM, right?
Mm-hmm.
It's colon print OnePlus RAM starts from what I can say 4 GB, right? 4 GB or 2 GB, it's up to us. It starts from or that model you can say. Okay.
Mm-hmm.
So next thing, for which thing we create object? OnePlus, right?
Yes.
OnePlus.
OnePlus.
X equals to OnePlus. Let's call the RAM charger
Sort.
and the circuit, right? Say this thing. OnePlus RAM starts from 2 GB, 5 volt charger is required, circuit is used, some circuit name you can specify, right?
Mm-hmm.
So that's a multi-level inheritance, right?
Clear.
Mm-hmm.
Any doubts till now? So how to write a class? Like I can't write football extends like we have this mobile, right? Is it correct way of writing that thing?
No.
No, right?
Mm-hmm.
So how to decide a thing exists, inheritance has this relationship or not? We can say when we have is a relationship. What is it? Is a relationship. Is a relationship means what? Can't I write OnePlus is a mobile?
Relationship between mobile. Yep.
We can write it, right? And mobile is a electronics.
Yeah.
Football is a outdoor game, right? So these are nothing but the easy relationships, right? All this comes under what? The inheritance. So if you want to have inheritance, you should have this easy relationship. And I can't write, say, football is a mobile. There is no sync, right? We don't say football is a mobile. Correct?
Yes.
So you understood for which things we can write how? Dell is a laptop. OnePlus is a mobile. Okay?
Mm-hmm.
So I want you to write the constructor programs, complete those two programs. One is zero argument and then one is parameterized. And then single level, we have two levels we have seen. One is single level and multi-level. Write your own programs also. Okay, if you execute this, along with that, try to write a new program also. Clear?
Okay.
Yeah.
So we'll see different types of inheritance. And we have one more thing, has a relationship. So how has a relationship works, that also we have to see. We will see tomorrow again. Okay?
Okay.
Any doubts in this today's session?
Rohit, Often we call it as function method. So there is no difference, right? If you're calling inside the class, that is a method. If you are writing, what is it? That is
What you're asking, like function and methods, how are they are different? You're asking, right?
yes,
Is that your question?
yes, Rohit.
We'll see polymorphism, right? Then you will understand.
Okay, okay.
Because polymorphism is a concept which has overloading and overriding,
Oh, okay,
and functions doesn't have that. So there is a difference, right?
okay.
Right.
I asked, I mean, often you use the term function and method. That's why I asked.
Right. I'll explain the things. So that's it for today. We'll meet tomorrow then. Okay.
Thank you.